I am Dr. Himanshu Sarkar. Welcome to all viewers in my YouTube channel. Already I have discussed in my previous few lectures regarding the thermal conductivity of class 11 syllabus. I discussed in my last class the concept of thermal resistance and equivalent series conductivity. Today I will discuss equivalent parallel conductivity. Before that, I request all the viewers to subscribe my channel so that you can get all the information regarding the next video contents. Now, last class I discussed what I discussed? Series equivalent conductivity. I told you in my last class, this is one rod, this is one rod, this temperature theta 1, this temperature theta 2, this is the thickness x1, conductivity k1, area of cross section A. Similar quantities for the second rod x2, k2 and A. And I told you in my last lecture that is this is called series connection. Here q by t is same. Q by t is same. That is the rate of heat flow is same in both the rods. So the K equivalent that is called equivalent conductivity. I told you that is x1 plus x2 by x1 by k1 plus x2 by k2. Already I have proved this in my last lecture notes. So if I consider lots of rods are there, one rod, two rod, three rod, looking like this, then K equivalent is equal to what? Summation over xi by summation over xi by ki, where I is equal to 1 to n, here also I is equal to 1 to n. That is for the n rods in series. The equivalent conductivity is this, and this formula is very much helpful for doing the numericals for the JEE and NEET level. Okay. Now today I will discuss similarly, I will discuss the parallel equivalent conductivity. All you know, I told you thermal resistance equivalent to the current resistance. That is in case of the parallel. What do you know? In case of the current flow, what do you know? That is potential difference is the same, current divides. But here is what? Suppose I am discussing the parallel equivalent conductivity. Here what happens? This is one rod, this is another rod, like stack one after another. Here we consider thickness is the same. That is, this thickness is x, this thickness also x. Area of cross section is different. Here is this is x, this is conductivity k1, this is area of cross section a1. For the another rod, that is x, k2, a2. And here all the rods are placed at the same temperature difference zone. Here is theta 1, here is theta 2. Here is what happens? Heat flow divides. Here what happens? Heat flow divide. This is suppose, here is suppose this is q by t. This is what? This is q by t for 1, and this is what? q by t for 2. That is q by t is equal to q by t for 1 plus q by t 2. As you know, as similar as the current, in case of the parallel, what happens? Current divides. Here what happens? In this case, heat current divides. Heat current is what? Q by T. Heat current is what? Heat current is what? Q by T. Q by T divides. Here Q by T actual, and here it divides. That is what? This is Q by T, and here it divides. This is what? Q by T for 1, and this for Q by T for Q by 2 for 2. So Q by T is equal to Q by T for 1 plus Q by T for 2. And you know, as last time I discussed RH is equal to what formula? X by Ka. RH is called what? Thermal resistance. Here the behavior is same for parallel combination. For parallel, what do you know? For electricity, 1 by R is equal to 1 by R1 plus 1 by R2. Here similarly, we can write down. Similarly, here we can write down that is 1 by RH is equal to 1 by RH1 plus 1 by RH2. RH1 is what? Thermal resistance of the one dot. RH is what? Thermal resistance of the another dot, which is connected in parallel. So we can write down, and RH is what? Equivalent thermal resistance. RH1 is what? Thermal resistance of rod 1. RH2 is what? Thermal resistance of rod 2, which are connected in parallel. And RH is what? Equivalent thermal resistance. So now I can write down the RH1 is equal to what? X. Here X is the same. I told you, two rods, same X, thickness same. K is what? K1, A1. Similarly, RH2 is equal to what? That is X by K2, A2. Now, actually the picture is looking like this. That is your X, that is K1, that is A1. This is another rod, corresponding quantity is X, K2, A2. So, now, and this temperature difference is same. Here is theta 1, here is theta 2. Now I can consider a single rod. I can consider a single rod. So the single rod looks like this. Temperature difference should be same. Theta 1 and this theta 2. And the area of cross section is what? A1 plus A2. Thickness is what? X. Then the conductivity of this single rod is called K equivalent. That is equivalent conductivity of the parallel combination. The conductivity is called here K. This conductivity is called K equivalent. So I can write down for RH of the system, RH is equal to what? RH is equal to X means what? X by Ka. K equivalent into A means what? A1 plus A2. So from this equation number 1, equation number 2, equation number 3, and this also equation number 4, I can write down from the sets of these 4 equations 1, 2, 3 and 4, I can write down 1 by K equivalent into X by, this should be X by K equivalent into A1 plus A2 is equal to, that is equal to what? 1 by RH, sorry, 1 by RH. RH means X by K equivalent into A1 plus A2 is equal to 1 by X by K1 into A1 plus 1 by X by K2 into A2. So I can write down K equivalent into A1 plus A2 by X is equal to K1 A1 by X plus K2 A2 by X. So ultimately what we can write down? We can find out X, that is the, so we can write down K equivalent formula is equal to what? That is A1, X is cancel out, that is equal to what? K1 A1 plus K2 A2 by A1 plus A2. This formula is very important formula for doing the numericals for the JEE NEET. I think all of you clear. Now I am stopping my class. Before that, I can tell you in my next lecture, I will discuss how the thickness of ice grow with time in this topic. Before that, I again request you to subscribe my channel. I am ending my class here.